Hello, good afternoon.
We're just going to start. Yeah.
Sorry.
Oh, okay. Okay.
Let me share the screen. Yes. Can you see the screen, Shravan? Everyone?
Yes, yes, listen. Yeah.
Okay. If you have any queries, then let me know. Uh, Mayuresh, have you emailed me something?
Okay, it
I
was
have seen
a couple of hello, it was 2 3 weeks back. Now, anyway, it is cleared. Query
the
is
formula
cleared.
was
There is no
correct.
problem.
Yeah, I think. But I
Uh,
didn't reply. Sorry for that. I have seen late. Yeah.
I must not remembering. Anyway, the
Okay.
problem was correct. No
You were
issues.
saying about the Newton open chords formula that I have mentioned in the previous.
Yeah, Newton. Yes, 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 yes. It
Is
was for
there
that.
problem
I'm
in
just
that
seeing
or?
my Saint items.
Okay.
No, there is no problem now. It is clear.
Okay. Okay. Fine. Yeah, I just share. Okay. So we have to study now some methods to solve the differential equations. Okay. So this is the last tutorial class I'm taking. So just understand carefully. Yes. Okay. I just pasted that question. So have you studied these solutions for ordinary differential equations numerically using some methods in the class, in the lectures? Just mm, okay. Okay. So what is Euler method? Anyone? Have you studied in the class? Euler method. We just first
Yes, you
discussed
can
that.
recall because
Yeah, I
actually,
just discussed that in the brief. Yeah. So what we do in the Euler method, suppose you have an ordinary differential equation, say y dash is equal to fxy, where y0 is equal to y naught. Then what you do is you try to approximate your function using Taylor series expansion. So let's do that first. So what is yx plus h? Say x is some point, then yx plus h is yx plus h y prime x, right? I can approximate like this. Wait, I just write this one. This is not approximation. This is equal to plus some remaining terms, right? Like this. That is your xi, xi 0x. So this is your error term, basically. So you know the value of y prime of x, which is given by this thing. This is y prime of x is fxy. So you can just substitute here, and so y plus y, if I omit this term here, so I just omit, okay, omit this term here, and you just do yx plus h is approximated as yx plus h fxy, okay? So this is basically your y1 is difference equation. This is called as difference equation. Y1 is y naught plus h f x naught y naught. Okay. Similarly, y2 is y1 plus h f x1 y1 and so on. So yn is equal to yn minus 1 plus h if xn minus 1, yn minus 1. Okay, and then you can find out the solutions. So you can see that in this method, this is basically your formula for, okay, I just write here, this is basically the formula for your Euler method. This is called as forward Euler method. You understand this method? Any issues in it?
Yeah, clear. And so one small clarification regarding this order term.
Yeah.
Whatever we are explaining, the difference
Yes.
equation, whatever order term is omitted, and we are approximating this as a difference equation.
Yeah.
But same
Omitting
as
the error term, we just have a difference equation.
yeah. Otherwise, it is a differential equation. Without error, it is shown as a difference equation. Correct, na?
Yeah.
Last assignment, there was one question with respect to that error approximation.
Yes.
So that question probably I think we had posted in that group also, common group, about that final what you can say, like we could not clearly get the answer for that.
Which question number? You tell me.
It's question number 8.
Okay. Previous assignment. Everything is fine other than that?
Yeah, 8. There was this was the issue.
Okay. You can
Because
email
now I
me
am
and just forward it to the tutor.
Yeah.
Okay.
So it is like a global error for integration
So
between.
there are two types of error. One is truncation error, local truncation error, and global truncation error. Okay.
Yeah.
So what is the local truncation error in this case? Can you tell me? Just right. What is the local truncation error?
That is x square 2 by y double dash.
Order of local truncation error, basically.
That is x square.
Order of h square, right?
Yeah, order of x square. Yeah.
And what is the global?
It is h.
Why?
Order of h.
Why it should be order of h? N times, and n is b minus a upon h. So it will be b minus a order of h, right? Because local truncation error means you go from x0 till x1, right? But for global, you go with x2 to up to xn. You divide by n. You multiply by n. You sum all the errors. This error, and up to this error. This is E1, E2, En. Minus. Okay, do you understand this? En. Do you understand?
Yeah. B minus a by h. Yeah, that is global is only between 2 points and local is full. Sorry, local is between 2 points, global is full.
Global is summing all the errors locally.
Summing all the errors.
Okay, do you understand this method? Okay.
Yeah,
So
here
what it
only
says?
last assignment, there was one question with respect to this global truncation error. If a function is given, f of x is x cube, and psi in the global truncation error, we have to find by trapezoidal rule.
Okay. Yeah, so there is, I have said about the truncation error of trapezoidal rule in the last tutorial.
Yeah, it was
I think
there.
we have seen that.
Yeah. The formula is there.
Yeah.
But when we utilize that formula and we apply that limits also, the value is not coming correctly.
Okay. Can you email me once? I just check it.
Sure.
And the
Sure.
question and solution. Okay. Question and solution.
Okay. Sure.
Questions. So this is Euler method, and this is you can say alternatively there is one name. Euler method is more popular, but forward Euler method is also can be used. But if someone says you If the question says you to calculate using Euler method, then you need to know that you need to calculate using forward Euler method, okay? But there are two types of Euler method. If question says Euler method only, just calculate by forward, but we will discuss backward Euler method also. So what is forward Euler method? Is it an explicit method or implicit method? Do you know about these? So it's an explicit method.
Forward, yeah, that is explicit. Mayuresh here will be explicit because it is not dependent on the future time steps.
Yes.
All on the previous time steps.
And we will discuss backward Euler method. Okay, let's see first. So what we do in backward Euler method, you just try to do is same as similar modifications. So yx minus h, we just go back in the time because the name implies backward, right? So yx minus h y prime x plus h squared by 2. Again, using the Taylor series approach. And so what happens is you can again substitute y prime x to be fxy, right? So this can be written as, okay, so we are just going in the back in time. That is this. So how do you like compute in this case? So what is the method? Now yx can be written as yx minus h plus h fxy, okay? So it's kind of approximation because I omitted the error term. And hence you can just say that. So suppose x is basically your h. So ultimately you end up with this type of thing. Yn is the difference equation in this case is this. Yn is yn minus 1 plus h fxn yn. Okay? This is the difference equation. So is it an explicit method or implicit method? And what is the local truncation error? Global. Yes.
This will be implicit method because the right and left both are having nth term. So it has to be utilized in every step. Yeah.
So this is implicit. And what about the local truncation error in this case? Local truncation error. Order of local truncation error is
order of h square.
Yeah, and global is same. Order of h.
Good evening, sir.
Yes.
Sir, once again explain what is the difference between explicit and implicit. I joined late.
Okay. I have not explained much, but yeah, because I have already answered. Explicit means the value of the quantity at nth time step must be dependent on the previous time steps, like n minus 1, n minus 2, and so on. Okay.
Okay.
Note. You understand now? Okay.
Okay. No.
So now can we solve this question? Okay. The velocity of body is given as function of time by this. Using Euler method with a step size of 5 seconds, the distance in meters traveled by the body from t equal to t equal to n seconds is most nearly. Okay, so Vt is given to us and distance in meters. Okay. So what is the equation basically? Since Vt is given to us and we are given some initial data, distance in meters is, okay. What is the distance? Singular method. I don't think so. They have given the distance, initial distance function. it is step size. Okay, so here what you can think about it. What is the I just write it here. So t equal to t equal 12 seconds with a step size of 5. The distance in meters traveled by body from t. What do you understand from this question? Can anybody explain?
So we are now the velocity given. We should find the distance traveled from t equal to 2 to 12
So
seconds.
a equals 2 and b equals 12, right?
Yeah, and the step size of 5 seconds.
5, 2, 3, 4, 5, 6, 7, 8, 9. Oh my God. So I just make big. 2, 3. So is it like 2 plus?
I guess 2, 7, and 12, right? That
Oh yeah, we don't need to write all things, right?
Yeah. 2, 7,
2,
12.
7, and 12, right? So h is basically your 5. And what is the value of n? What we need to find at 12? What is the differential equation in this case?
Velocity, like change in time with respect
Is
to.
it that?
Yeah, distance with respect to time is velocity. Yeah.
But they should give the initial data at 0, right? What is the initial value at t is greater than equal to 2? We need actually. So we need the distance.
Here they are asking find the distance only. Here they are asking us to find the distance only.
Yeah.
So on integration, we should get the distance.
But we need initial value, right?
Okay.
No, they said use method. Right? Suppose x2 is something like 100. They should provide some value like initial point of distance like 100, something like that. Okay. And then then you just do start from. So what is the value, initial value here? What is, how do we proceed in this question? I just do a random question like that. You can understand why it's amazing question. So like if you have something like dx by dt is equal to some function, say x into t, xt, say, right? Then how use Euler method, and x0 is equal to say x naught. Any number, say 1, it is x0 is 1, say. Then you have to use Euler method. How do you use it? So what is the difference equation? X1 is equal to x naught plus f t naught x naught, right? And what is t naught here? T naught is 0 and x naught is 1. So x1 is 1 plus f of 0, 1. And this is fxt. Do you know? What is f0, 1? This is 0. So x1 is 1, right? Similarly, t1 is now h. What is h here? H, just take 1. So t1 is 1, x1 is 1. So you can find x2. x2 is x1 plus f t1 x1. What is x1? x1 is 1 and t1 is 1, 1, 1. So it will be 2. Can you continue like this wherever you want to find? So the distance at, suppose x1 means the distance at x at 1 is equal to 1 seconds is basically your 1 and approximately 1, and distance at basically 2 seconds is approximately yours 2. Can you do like that? The main thing is to understand the implementation. Do you understand?
No, this is actually like with an Euler method when we are going. Yes, we are finding these values.
Yeah.
Then finally we have to take it to.
What are you saying?
No, finally, how we like we are getting values of x at different time intervals, right?
Yes.
So we have to take it up to 5 seconds. That's what you are telling. If they are asking up to like question is something like with a step size of 5, but the distance traveled between by the body from 2 to 12 seconds. There it is. Question is different.
Think
Here
so.
it is okay.
Yeah,
Here
but why they are? It is again. We know the velocity and distance from the equal to the equal 12 seconds. So basically you need a distance at 2 seconds and you need a distance at 12 seconds and you just need to subtract both of them, right?
But if I integrate this velocity equation with respect to time,
Yeah.
or
but you need initial data, right? For integration also you need initial value. You can't integrate.
okay.
Yes, you need a constant. There is a constant after integration. Do you know that? So you need an initial data. I think there's some issues. We will get back to similar questions soon. I think there will be. There is one question similar to that. Gravity and all. Just go with that. Okay. But the main thing is to implement. I'm not going to show any, like, I just want to show the implementation of Euler method in some random examples, and that's it. So here forward Euler method is just applied in this way, and
Yes,
it's easy
can
to.
I see the options? Is it 2500 some option is there?
Yes.
Yeah, I'm getting that.
How you are getting, like, you are using Euler method or?
What I assume, no? Yeah, by Euler method only.
Okay.
I assume that at t is equal to 2, no? I just took s0 as 0. Initial
you
distance
assume
I started with that.
x2 is 0.
Yeah, that means at t is equal to 0, no? Just started the displacement. So yeah, I have taken that as 0.
Yeah.
So x1 is equal to 0 plus that is h, that is 5, h is 5, and in bracket 200 into ln of 1 plus t minus t, no? So t is nothing but 2. Yeah, so with that s1 and s2 is, so I'm getting 25 something, 2500.
Yeah. Okay, you are trying. Okay.
Yeah. Okay.
That's fine. But you know the implementation anyway? How to implement forward Euler method?
I did my Euler method only.
Okay, yeah. Anyone else?
So can you please repeat again once?
What
you want me to
Euler
repeat,
method?
Sarvanand sir?
Yes, Mahirish, can you please?
Yeah, actually what we did, no, velocity is nothing but ds by dt. So the other ordinary differential equation is also nothing but dy by dx is equal to f of xy, is it not? So here also it is ds by dt is equal to the function.
Okay.
Yeah, and now I have assumed that t is equal to 2. I have assumed that this initial displacement is 0. So with that, the first step, that is S1. S1 is equal to S0 plus h into f of x0, y0. You got it? S1 is equal to S0. That is y1 is equal to y0 plus h into f of x0, y0. No?
Correct.
Likewise, S1 is equal to S0 plus h into f of x0, y0.
Okay.
So S0 is 0, S0 is 0, and h is 5. Step size is 5, and f of xy is nothing but you have to put t is equal to 2. Time is equal to 2. Yeah, and then 5 into 200 into ln of 3 minus 2. So you will get S1 with that. Initial.
Yeah, S1 value is at distance at 7 seconds, right?
Yeah. Distance at 7 seconds, and then S2 you will get further. Like exactly like by using this logic.
S2 we have to go with t equal to 12. Okay, S2 we have to give 7 and 12. So like that S2, S3 we have to find.
Exactly. So
Okay.
in fact, we have to add both of these, and we will, because both of these things need to be added, because those will be the distances at each
Yeah, they are
interval.
just, I think, using this distance and displacement. They should use displacement in this case.
Yeah.
And displacement should be 0 initially. They are.
Yes.
Okay.
Yeah.
I don't know, but they should provide initial conditions for anyways. Okay, so we can just see another question using that. Given and step size, the value of 5.9 using the Euler method is most nearly is. Okay. So we can solve, I think, using, okay. You know how to solve with backward Euler method? So it's the similar, second is similar question. I won't be doing that. Similarly, by forward Euler method, this. But I want to give you the backward Euler method justifications, like, okay. So if you want to solve this similar equation using backward Euler method, how will you do that? Okay, dx by dt is xt. Yeah. So what is backward Euler method? Anyone remember? Xn is xn minus 1. And we have what we have? Plus h f xn yn, right? T and xn. So what is x1? X1 is x naught plus, say, h is 1 into f t naught x naught. Sorry, t1 x1. So x1 is x naught plus x1 t1. And you know the value of t1, right? What is t1? 1. X naught is basically your this is the value of x naught. X naught is 1. Why it is like that? Confused? H is ft1 x1. I think there is some problem with the above method. Yx is yx minus h plus h minus, wait a second. This is not correct. It's backward. Yes, I think. Okay, so yx minus h is yx minus hy prime x, and yx is equal to yx minus h plus hy prime x. Okay. And what is the issue with it? Same t1 x1, and this is x1 t1. T1 is your 1. So x naught plus x1, and x naught is 1. 1 plus x1 is x1. Oh, it is possible. This is not good. Yeah, I think I should use some another equation like that. Okay, I just use this and we try to solve it using backward Euler method. No, it's not going perfectly. 3 dy by dx is sin x minus 5y square. See, simple equation is sin x and y0 is 0. So what is your backward Euler equation? Says that yn is yn minus. Okay, so it's like yn minus 1 plus h fx and yn. Yeah. So here fy0, you want to find y1, y0 plus h, fx1, y1. Say h is 1. Then y1 is y0 is 0 plus h is 1 into fx1, y1 means sin x1. So y1 is basically your sin x1 and which is basically your sin. I just want to consider some more equation like sin x plus y into a function of xy. That would be sin x plus y1 sin x. I should not take like that. Okay, let's take sin x to be. Yeah. So y1 is sin x1. So does that work or not? Y1 is sin x1 and y2 is, you can again use the same. The idea is that implicitly it should come like that. Plus fh x2 y2. And this is sin x2 h plus h is 1, x2 is 2. So I just write 1 sin 2 and y1 is sin x1, which is sin 1. So you get y2 easily. Yeah. I want to show more realistic example, but since is there any Euler method, backward Euler method discussed in the class or not?
There is one assignment question this week on backward Euler method.
Okay. Can you tell me the question? You can just try to solve.
Let me.
Okay. Yeah.
Just 1 second.
We can work on that. I have to choose specific question for that, I think. Sure.
Just one small clarification here that when we go to y2, y1 you can use from the previous step, right? Whatever you are getting.
Yes.
And then x1 is 1. You are taking x1 as 1. Previous step it is x0 is 1.
Yeah.
Sorry, x0 is 0, right?
Yes.
Shall I tell you?
Yes.
It is question number 5 of this assignment 12.
Can you tell me the equation, please?
Yeah, y dash is equal to minus 2t y square. Y dash is equal to minus 2 into t into y square.
Okay.
T lies between 0 and 1 and y of 0 is 1. And h is equal to 0.2. Find out
you
y
should
is
use
equal
for
to
those equations which are non-linear in pi, I think. The Euler method, backward Euler implicit methods, right? And y0 is?
y0 is 1 and we have to find out y of 0.4.
Y of 0.2.
0.4.
H is 0.1.
H is 0.2.
H is 0.2.
H
Okay.
is equal to 0.2.
H is equal to?
0.2. Correct.
Yeah.
0.2.
And we have to calculate y of 0.4.
Okay, you wanna try with me? Let's see. Using backward Euler method, right?
Yes.
Yes, yes.
Yeah. So how will you do that? Y1 is y0 plus h. This is f ty plus h f t1 y1, right? What is the value of t1? What is y0? 1. What is h? 0.2. What is ft1 y1? Which is minus 2 t1 y1 is square. T1 is 0.2, right? I just write 0.2. And y1 is? We don't know y1, right?
We don't know the y1.
So y1 is, what is the after solving? 0.04, 0.08.
Sir, this is y1 square. Now function is minus 2t y1 square.
Okay, it's y1 is square, right?
This is y1 square.
Yeah, it's fine now. So what you get here as 0.08 y1 is square plus y1 minus 1 is equal to 0. So you will get some values of y1, right? Once you get y1, then just find y2 using that.
Using quadratic equation, we have to calculate. Sir, this is roots.
Yes, you need to calculate using quadratic rule. You wanna do this now? Or you can do this later.
No, sir, at least we have to do one problem because after that we are not getting the correct answers.
Okay, yeah, we can try. Yeah.
The last assignment we got 5 wrong answers for me.
Okay.
We are not getting exact answers what they given. Some we are getting, I don't know about the others, but
There were 5 wrong answers in the last assignment. 11. Assignment number 11.
I lost 5 questions.
Has anyone faced a similar problem?
I don't know about the others with these two.
Yes, actually, question number 8.
Yeah, Mayuresh.
So
yeah.
Question number 8, we have raised the query. I think that's a wrong question. Okay. I lost. Okay. Other than that, question number 9, I got some answer and I have clicked it because I suppose it is correct, but it's wrong as per the result.
Okay.
Sir, how many of you got, sir? You got all the other 9 correct only.
Okay, I got
last
it.
Assignment. 11th assignment. Some of the question we didn't get the answers at all. It is not matching. I don't know.
Are you facing the similar problem or others also? Like except 1 or 2 questions?
I don't know, sir. We don't know others.
Mayuresh, have you faced the similar situation?
I got the answers. Other than 2.
Got. Okay.
Except 8, I think others are okay. 9th again, but there was an error. Yeah.
Okay. So can you solve it now and tell me what are the roots of this quadratic equation? We can try one question at least for assignment. And once you got y1, just do the similar. Y2 is y1 plus h ft2 y2. And y2 is, what is the value of y1? Just tell me and then we can find out what is the value of y2. Are the roots coming to be real or one is complex number? But they both should be complex number and real roots.
These are real roots. Yeah.
So which one we need to take?
Sir, one is we got minus 1, other one is minus 25 plus 5 root 33 by 4 something.
One is you minus 1 and other is minus 25 plus minus
0.9307. One is
log.
minus 1, is 0.9307. 5 root 33 by 4 like that. That is nothing but 0.9307. 93.
Okay, can tell me the decimals.
0.9307.
Is that? Okay, you can try with both of these and check the answers, right? So it's close to 1, but you can't take
Sir,
1.
if they given this much lengthy, how it possible to do all this problem within the time, sir? The problem seems to be lengthy.
Not this much lengthy, I think it would be.
Because all the problem from last 4, 5 and we are doing because
assignments are designed to make you think about more and spend more time, but question papers will be different.
Okay, sir. Because without calculator, some of the problems we are unable to do also.
Yes.
It is very difficult because if you see the above equation, it's 12.002 means b square minus 4ac like that.
Yeah.
It's very difficult, no?
Yes, so -1 is fine, then y2 is -1 plus h is 0.1, 0.2 into -2.2 y2 square. Then you just need to solve this equation again, I think. So it is 0.08 y2 square plus y2 plus 1 is equal to 0, right?
Oh, just to clarify whether that root 1 is correct, Mayuresh, you also got the same thing?
0.937, 0.9307.
Okay.
Yeah.
Okay.
Here also almost only in the term -1 is +1. Okay, sir.
Can you check whether it's correct?
I will actually answer. Okay. After one more step, no, you will get answer which is available in the options.
Yeah. So try once and tell me what is the correct option. What is the value of y2? This is the last step, right?
Sir, by using y2 is equal to -1. -1. It is one is 1, the other one is 1 and -1.096111.
What is the 1 and
y2 1 and minus 1.09611.
okay? So is it in the option?
No, one small clarification here, Yash. Actually, the T1 when we take 0.1, T2 should be next another step addition, 0.4.
Oh yeah, sorry. It's just it should be T2 is 0.4, right? Yeah. So it should be multiplied by 2 again and should be 16.
0.16.
Yeah, can solve it. Yes, what is the answer for that?
1 and -1.2.
Is it in the option?
-1 minus, no sir.
No?
There is one mistake here in y1, no? Y1.
Yeah.
Y1 is not -1 and 0.93. It is actually -13.43 and 0.9307.
What sir?
Y1 value of Y1. Yeah,
Okay.
-13.43 and -13.93 and 0.9307.
-13.43
and 0.9307.
Okay, can you see here? Yeah.
Yeah, it is correct now.
Okay, now you have something to do next.
Yeah, from here 0.9307 is to be taken. Now this is not able. I'm also not able to explain why we should take only 0.9307 and why not minus 13.
No, we if the question is not saying anything, then we can take -13.93 also.
Okay. Probably you have to check.
So you need to check for every values. Yeah.
Okay. Anyway, I have taken 0.9307. With that, I got the answer.
Okay.
What the answer you got, sir? Y2?
I got 0.8224.
Okay, so you can solve it using that.
Using the which value you got, sir?
Y1? 0.9307.
Okay.
0.9307.
But the thing is that you need to know how to apply backward Euler method. Yeah. Yes. Anyways, let's discuss. So this method is more time consuming, right? Backward Euler method.
Yes, sir.
So if there are, so use implicit methods for solving system of equations. Okay. Okay. Now, we can talk about something about the error, let's say.
Sir, via 0.6 using Euler's method, h is equal to 0.2 means we have to use the same. They didn't mention backward or forward, no, sir, in the assignment.
What?
Determine via 0.6 using Euler's method. H is equal to 0.2. It may be the same equation. They didn't mention backward or forward.
Okay, so they said by Euler method, right?
That's
so I have explained in the starting, if they say by Euler method, then you just go by forward Euler method, okay?
They didn't mention means we have to use the forward.
Yes, yes.
Backward means we have to use the backward.
Yes. If they specifically write backward, then you have to use backward, otherwise. All right. Trying to it. Okay. So we have another question in the box. The solution to IVP is approximating using Euler's method. With this, find a bounds for approximation error. The exact solution is yt is equal to this. So we have to find the bounds at equal to, but we can find, I just show you the method. So you are given a differential, I'm not going to solve it. And then you are given something like a differential equation, any differential equation, say, then you can use Euler method to find out the solution easily at n+1 time step. Here h is 0.25 already given, and y naught is 2 already given, and t naught is 1. Okay. Then after finding the solution at, say, so y1 is approximately y of 1.25. So you need to go to y4 to get the value of y2, right? So once you get y4, which is an approximation value of y2, then you can find out an exact solution is given to you, right? Exact solution in 2 is 2 log 2 plus 4. Right? Then you just subtract y4 minus y2 to get the absolute error. And whatever the value you get, then just check it from here, which is the option, correct option. Which is the bounds. It means that you need to find the value of a, which is less than equal to something, greater than equal to.
Can you please repeat again? I just missed it from the beginning. This question.
Yeah, so this question is about the error. Find the bounds for approximation error at equal to 2, right?
Okay.
Then how can you do that? Okay, this is one thing, but I would say that you don't need to use for that. You don't need to use the approximation errors like that. You can go by that way, direct by formula, I think. Let me see. So the formula for error is you have h square by 2 y double dash xi. But what is y double dash? Here is nothing like that. F dash. Okay, so this I told you that you can do by this. You just go till y4, right? Y4 is the approximated value of y2 using Euler method, and then you just subtract the exact solution value at 2 and y4 approximated solution, and then you get the value of error. Do you get it?
Yeah, yn plus 1 is yn plus h f of x on that equation is
Yes.
okay. Then y1 we are taking as y 1.25.
Yeah.
Or h is 0.25, then
Yes.
so that is from that y 1 plus y by t.
Yes. Y1 plus 0.25, yeah. Yx plus h. Any problems? Are you there?
No, actually at t0 equal to 1, y not equal to 2. That I am not getting. Actually at t equal to 1.
Yeah, just see. At 1 is a y naught. At 1.25, it is y1. At y2 is 1.5. Y3 is 1.75. And y4 is 2.
Yeah.
All right?
Yeah.
And h is 0.25.
Okay. Yeah.
Then you use Euler method.
Okay.
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 Now we just go to another method. We don't have much time to discuss, I think. Modified Runge type to discuss and Taylor method. Okay, we can discuss Taylor method, then we can do questions on that. Okay. Okay, just give me 5 minutes. I will be back. I just start with Taylor method.
Yes, sure. Can you just go up that
Yes,
question?
yes,
Can you
yes.
this question?
Yeah.
Yeah, just keep it there. Slightly
Okay.
zoom, please.
Yeah. You want to solve it?
Yeah.
Yeah, okay.
You're taking 5 minutes, right?
Yeah,
the time is
just
there.
solved. Yeah.
Okay. Sarvanan sir, you got the answer? Are you
Yes,
trying?
I'm back.
Yeah, I'm just doing my rush Y3 and there.
Okay, we can continue if required. We can come back to this.
Yeah, just come
Other
back.
people practice.
Yeah. Right, so we can discuss Taylor method. Okay, so it's just an extension of Euler method. Okay, so I can just work with some example to discuss that. Yes. So use Taylor method of order 4 to approximate the solution and this for the following IVP, initial value problem. Okay, with h is equal to 0.2. So up to how many values we need to find? We need to find y1 and y2 only, right? In this case. So what is the method? The method is the y dash is given to be y minus t square plus 1, which is say fty. Y0 is y naught, which is 0.5. Okay, so the method says that y say x naught plus h is given by y naught. You just use Taylor series expansion. H y prime x naught plus h square by 2 y double prime x naught. So it's the question is saying of order 4, so we need to go by 4 terms. Plus order of h to the power. We need to stop at here, right? The question is y prime of x is given to us ft. What is this? Here I am taking x naught, not t naught, so I just take x, and x. Okay, x. Yeah. So y prime of x is given by fxy. That is already given us to us. We need to find y double prime of x. So how do you find y double prime of x? Anyone? We need to stop till here. We need 4 derivatives of y. How do we?
y prime x n plus 1 minus y prime x n divided by h. Is it like that?
No. You know y prime x, right? You just need to differentiate this. So what is this?
Okay.
F prime xy means it is basically del f by del y. And this is what should be the correct way to say? How do you differentiate this? This is basically fx plus fy y prime. Okay. No, it's like this. You use Chan rule basically. And y double prime x is you need to differentiate this fx with respect to x. Yes. So you need to differentiate with respect to x, sorry. Right? So it is del f by del x. And this is del f by del x, del f prime by del x, basically. So what is this? We get fxx plus fyy prime square plus fyy double dash. Okay. Like this, we need to calculate what is y for x. f triple x plus fyy y prime cube plus f5y 2y prime and y double prime plus f5 and this is y triple prime. Do you understand this? Then once you get these expressions, you need to substitute in first equation to get your desired value. So you get y1 from there, from first. Yes, any doubts? Check. You understand this formula?
Understood.
Okay.
Sir,
And what
Oh,
is the
yes, there is one query. Can I
yes,
ask?
yes.
Actually, this I understood. There is exactly similar kind of question in the assignment where they
Yeah.
are asking the bound of error for 3-term Taylor series and
Round of error
equations are
from
given.
3-term Taylor series.
Oh, yeah, for 3-term Taylor series. So
Okay.
how do we find? Do we need to take fourth term directly as a error?
No. If they are saying 3-term, then you just take 3 is 3. You need to stop it here.
No, but no, but we don't have any exact. We don't know exact solution. So how do we find out the error?
The error will be this then, h cubed by 6.
Oh, okay. And what is
Yes.
to be done with y 3 x of x naught? Like
That you
third
need to
derivative of
do
y.
is,
Sir,
yeah,
they
you
given
need,
the second order differential equation, sir, for that y double dash plus y dash.
oh, they have given second order differential equation.
Yes, sir, y double
Third
Then
dash.
you
order,
can
third
convert
order.
into system of differential equations. You know how to convert that?
Is it possible to solve similar kind of or the same problem?
I mean, similar kind like,
Or same?
Sir, okay, we will. Sir, here, sir, one more doubt, sir.
yes.
The same question, the second question is the given the initial value problem. First three terms in the Taylor series for u of t is given by, they ask the what is the solution. U of t, instead of y, they use the u. Hello?
You want to solve it here? We can try. Okay.
Write down, sir. Because I am getting
Okay.
all the values are 0.
Can you tell me the question?
U dash is equal to t square plus u square.
U dash is equal to
T
square
square plus
plus u.
u square. U of
Yeah,
0 is
this
equal to 0.
u of 0 is equal to 0. Okay.
That means here, sir.
And what is h?
You have to write the first three terms of the Taylor series.
What is h?
H is they're not given u of they're not given h, sir.
Why?
We have to write in terms of t. The equation is the first three terms in Taylor series for u of t. That's all. H they're not given.
Which question number it is?
Second question. Given the initial value problem, u dash is equal to t square plus u square. U of 0 is equal to 0.
Second, maybe. Question number 12.
Question number 2, sir.
Question number. I don't have the assignment, I think. Trying to find the similar one. Let me see. Okay, so it's like that, and they are trying to say to find out the u of t, right? Okay. Using the which method? Okay, in this, I think this is not about any method, right? This is not about, don't need to find the solution here. Don't find solution.
Taylor series they're asking.
Yeah, you just use Taylor series, 3-term Taylor series. Use Taylor series expansion.
Then no need to take the values of initial condition, then we'll get only that, then the expansion will be.
There is like, I can do like that. U0, you have said it is 0, and U prime 0 is also 0, right?
U double prime also 0.
Then you can find out U double dash is equal to 2t plus 2u u dash, which is
plus 2u dash square.
Double prime 0 is also 0, right?
Everything we are getting 0.
Like that you can do similarly, I think, right?
But they are asking only first three terms means, oh, okay. Why triple dash also we have to calculate.
So is anyone understand this question other than her?
Actually, it is actually first non-zero terms. I'm getting it. Actually, it is asked about first 3 non-zero terms. What probably, actually, what sir is getting is first all 3 zero terms. No, it is not so. Actually, it should be first 3 non-zero terms. That is what is asked, and we will get it if you go up to U11. Yeah, 11th derivative. You will get it.
Yes, you can try. I'm not able to solve all the questions, right? Which question you were saying, Mayuresh, to solve for approximation error?
No, I was asking about question number 1. Just before, let me just clear this doubt. Can you go a little up? Actually, the very next derivative here, no, you see U double dash, Yash has written, U triple dash, if you see, no, 2t will become 2. Is it not? 2t will become 2. So that will be non-zero, first non-zero term.
Correct.
You got it? Yeah, that's how. So yeah, U triple dash, if you see, you will get 2. You will get 2. U triple dash 2. Likewise, no, U8th term, 7th term also will be non-zero, and U11th term will be non-zero. You please try.
Okay, sir. Then what is the one more thing here? In place of h, what we have to substitute here? Error.
Not required. H is not required. You just have to calculate U of 0. You try. You put U of 0 values everywhere. That's all.
Yeah.
Are you not following me?
No, sir.
No expansion required.
Expansion is y of x naught plus h, na? You have to take u of x naught plus h.
Yeah, h, okay. Probably h you take 1. You will get it.
H is equal to 1.
Yeah, you just, because that is not important here. You take h as 1. You will get the answer.
Okay.
Yeah.
Yeah. Okay, I'm going to discuss assignment problems much, but I can do. Yeah. So which one is first question?
Y double dash, if you can, y dash.
Yeah. Y triple dash plus y dash is equal to 0. Yeah, y triple dash plus y dash is equal to 0. Yes, are you following me? Yeah, y triple dash plus y dash is equal to 0.
Okay, you are saying about the first question. Okay.
Yeah, first y triple dash plus y dash is equal to 0. Y of 0 is equal to 0. Y dash 0 is equal to 0, and y double dash of 0 is equal to 1. And it is asked to find out bound of error for 3-term Taylor series.
Bound of error for 3-term Taylor series. Okay.
Yeah. This
How do you do that? Can you guess? And what is h?
Not given. Okay, what is given is t is bound is given 0 and 0.2. 0 and
Okay.
0.2 is t is bound.
So we need to find
0.2.
Okay, so y triple dash plus y dash dash is 0, and what you need to find, so y triple dash is basically minus y double dash, where y triple dash 0 is 0. Y triple dash 0 is 0, right?
Yes.
No, the y triple dash is not given. Y double dash 0 is 1. Y double dash 0 is 1.
Yes, but you can find y triple dash 0 also.
From that y triple dash is called minus y double dash.
Okay,
yes,
you are correct.
That's,
you are correct.
Yeah. So y4 is what? Minus y triple dash plus y dash, y double dash, and y4 0 is also 0.
Yes, sir.
Like this, you can find y5, right? And y5 0 should also be, I think, whatever. Then you can find y6, y7. You have to stop it when you get 0, 0, something like that.
No, but where shall we stop?
We
Because
should
it is
stop at
the
y5.
Wi-Fi or third non-zero term?
Wi-Fi is
So we need to stop
the
it. Because
okay,
see, first y0 is 0, y dash is 0, y double dash is 1. So likewise, y double dash term is non-zero. So likewise, we will get two more terms. And probably we have to
okay. So
stop
what
there,
is the Taylor series says that yt is y0 plus t
h into y dash.
y dash
Yeah.
0 plus t square by 2 y double dash 0 and so on, like, right?
Yeah.
And what is the value you're getting? You are getting y triple dash 0 to be 0. Okay. And wait a second. And y double dash 0 is 1. So you will get this term, right? Okay, wait. You will get this term, right? This term will be 0. This term will be 0. So it doesn't matter. Y triple dash 0 is 0. So it doesn't count. So you need y double dash 0 and so on so forth, right?
Yeah.
And t to the power 24 y40. Y40 is also 0, right? So
Yes,
this
sir.
term doesn't
is
count.
Yes.
T to the power 5 by 120 y50. Is it non-zero or 0? I don't know.
Okay, that we need to see.
Yes.
So likewise,
So you need to
okay,
retain
three terms
only
are
3
there.
terms.
We get -1, sir.
Okay, it's -1, then it is non-zero. So we
Yes,
just
sir.
take
Y double
-1.
dash square will get, that is y double
Yes.
dash value is 1.
And
Y-
y60, y70, all these are 0 maybe. I don't know. And you will get some like, I don't know,
No, yes,
whatever.
sure. Okay, so we will get till this point, and
something
then the
like that.
question is bound of error. The question is bound
Yes.
of error now.
Yes. So
So
if
that
you are
means
stopping at
after the
suppose t, yeah.
yes,
If you
after
are
the
stopping,
third term, fourth term we should take, right, for the error.
yes. So the fourth term should be like some t to the power 9 or t to the power 10. I don't know. Right, whatever.
Okay, because h
y9
also is not
outside.
given here. I don't.
Suppose it is the term.
What-
Fourth term is this. Then you have to find the maximum of this. And
But h should be known here. So h is not given.
why h should be known here. I don't know.
Oh, that's it. Okay, t.
Yeah. Don't need h. So what is the y9 derivative? You can calculate, I think, right? And y9 derivative would be whatever. Then you just take the maximum from t 0.2. Okay. Then that will be the bound.
Okay,
It
t
can be
taken as a
T9,
maximum only.
T11 or whatever. Yeah. If it stops at t to the power 8, you get non-zero term, then the next term will be the error, right?
Right.
And then you can bound it. Okay.
Sir, y power 9 means it will so many terms now, sir.
Y power 9 is?
Y power 9th derivative means at xi means it will have so many terms now.
Yes. Y power 9 derivative means
initial
you can find the derivative, right?
At the initial point, the derivatives may be 0, but at xi, all these are not equal to 0. No?
Yes.
We'll get the big polynomial.
No?
Why 9th derivative?
You calculate this only, y9 derivative of t. That's it. Don't use I. Can you calculate 9 derivative of phi? What is 9 derivative of phi?
9th derivative.
Yeah. How do you calculate it? You just calculate using the differential equation you have, right? Just try to calculate from there. Okay. So similarly, I don't know. Yes, so I was discussing another stuff. Yeah, you were saying about, okay, this is the one thing. And other thing is, yeah. So can you tell me this one? What should be the local truncation error in Taylor's method of order n? What is the correct answer? Yes.
n+1.
Yes, and
Order
global?
of n+1.
Global is n.
Global should be divided by 1. So n.
Yeah, so the Taylor's method of order n, in Taylor's method of order n, you need to retain up to n terms, right? You need to retain till yn.
Yes.
Order of h power n.
You need to retain till this point, and the rest of the term is your error. Okay. I want to discuss another method. This is
just yes. Can you just explain one more time this one? Yeah.
Yes.
Can you please explain one more time?
Of h power n+1.
What is the order of error?
Yes. Because nth derivative, it is we understood last y power n, h power n by infinity.
Yeah.
After that, the derivative. That means it is order of h power n+1.
Yes. Do you understand, Shravan?
Okay, so now that order of h power n+1 is okay. Then solution the step size is h. The local truncation error.
Yeah.
Okay.
Okay, so this can be done using this Euler method. Don't have much time. I want to discuss some other methods. Okay, so I just discussed modified Euler methods. What is that? And we just discussed
RK method is
RK method also we just discussed. And
equations also.
Let me discuss this question 9 and 10. So for question 9 and 10, you know the exact solution, right? And you need to apply Taylor method of order 2 and Taylor method of order 4. So using the same approach, you can do that. And I just discussed it earlier that you need to find the error. How do you find? You just take yn minus y approximate at tn, the absolute error. And you know exact solution value at tn, right? Just that. Okay, let me discuss methods now. Okay.
Modified Euler's.
Yes. So what is modified Euler method? Discuss that. So it is okay. So I just write the statement. So modified Euler methods is you just have to calculate the first value, which is y1. It is y0 plus h by 2 f x naught y0 y0 plus y1. Okay, y0 dash plus y1 dash. Okay, y2 is y1 y1 dash y1 dash plus y2 dash. So is it an implicit or explicit scheme? Explicit method? Implicit, right? Yes. And what is the yn? Yn is yn minus 1 plus h by 2 yn minus 1 dash plus yn dash. So it is called, I think, trapezoidal method also. You just know that. It has order 2. Local truncation error is of think here. What's the order of this method? Can anyone tell me just looking at this?
H by 2.
What?
Order.
What is the order of this?
Up to y dash terms are there from Taylor
Yes.
series. So
Order 1.
yeah, so errors. Okay.
How can it be order 1? I don't know.
No.
Order of h cube.
2, I think.
Order of h cube, right?
H cube.
It is the local. And what is global? Global is 2. Order of h square, basically. All right. We just discussed one example for this. So in this example, y dash is 1 plus y by t. I just record this.
Yes, just one question query.
Yes,
Actually,
yes.
we, from this looking from this formula, no, we cannot directly say the order, because if you see the
Yeah,
proof,
how do you
no,
say
there will
that
be,
then?
otherwise this y double dash term is not there in this, no. So
Yeah,
somebody
you
can
can't say.
misinterpret also that.
You used to use
So
by Taylor
because,
series, yeah.
yeah, because y double dash need to be substituted by y dash, and then only this formula will come. That's how.
Yes. You know the
from this,
derivation
we
in
cannot
you
say.
have seen the lectures or what?
It was shown in the
Okay, it
lecture.
was okay. It was shown, yeah, then it's good. Okay. So I just discuss this problem. So y dash is 1 plus y by t. T is between 1 and 2, and y1 is 2. Determine y1.5 using modified Euler's method with h is 0.25. Can you try with me? So yn is basically yn minus 1 plus h by 2 yn prime plus yn minus 1 prime, right? What is the value of h here? 0.25. What is yn prime? What is yn prime? It's f tn by n, right? Which is 1 plus yn by tn. And you know the value of, so we need to find basically for n is equal to 1 first. So y1 prime is 1 plus y1 by t1, right? And t1 is 1.25, so 1 plus y1 by 1.25. Okay. So y2 is, so y1 is y0 plus h by 2. H is your You know y naught. Y naught is what? Okay, just I write first. What is y naught prime? Y naught prime is f t naught y naught, which is equal to 1 plus y naught by t naught, which is equal to 1 plus y naught is your y naught is 2. So it is 3. Okay. Can mute it. Prasanna, can you mute? Yeah.
Y naught is 2?
Y naught is 2, right? Because y1 is 2. Y at t naught is 2. T naught is 1. Okay.
Okay, that is okay. Okay. So okay.
And then you can y1 is y naught is 2. So 0.25 by 2 y1 prime plus y naught prime. Y1 prime is 1 plus y1 by 1.25 plus y naught prime, which is 3. Then you can find out what is y1 from this equation, right? We can find y1. And once we can find y1, we can find y2 from the second. Okay.
Show that last line. Last line comes from?
Yes. Last line, this comes from this. Okay.
Always we have to use the present value using the Euler's, I think.
Yeah.
Euler's formula. Present, and we have to modify that y1.
Okay.
First equation that y1 actually we have left as it is, right? It's supposed to be y1, y dash 1. When we have put 1 plus y1 by 1.25.
Yeah.
That y1 is left.
Yeah, y1 is left. You need to find y1. Yeah.
Okay.
Sir, using
I
the
thought it is
Euler's,
1. Yeah.
the y1 initial value.
Yes.
y1 initial value by using the Euler's formula. Y naught plus.
No, you can't find using Euler's formula, right?
y1, sir. Previous
y1, we have to find y1 using this formula, modified Euler method.
We are using that y1 in this formula, no, sir.
We don't have value of y1 initially.
Yes, sir. Again, we have to use it just like the equation, quadratic equation.
Yeah. No, it's not a quadratic equation.
y1 equal to directly. y1 will bring on the left hand side.
Yeah. We can solve for y1 and find the value. Yeah, that is modified Euler method. And we have the next one. What happened to my screen? Okay, we can have the Runge-Kutta method of order 4. Is it being discussed in the class? RK method. RK method is being discussed.
I guess it is not discussed.
Okay. I just discussed the formula, and you can use the similar iterative techniques to implement that. Okay, so if you are given a differential equation, say dy by dx is equal to, just see carefully, fxy, and you are given the value of y naught is equal to some y naught, and you are given some h, then how do you find? The formula is given by k1, say k1 is h times fx naught y naught, k2 is h times fx naught plus h by 2 y naught plus k1 by 2. So first of all, you need to find out k1, then k2 using k1, then k3 is equal to h f x naught plus h by 2, y naught plus k2 by 2. And then you need to find k4 using k3, h f x naught plus h by h and y naught plus k3. And then you need to find k, which is basically the sum of, okay, I just write, then y is y naught plus, this is y1 is y naught plus k1. 1 by 6 of k1 plus 2k2 plus 2k3
plus 2k3
k4.
plus k4.
This is your formula. Okay. This is your fourth order Runge-Kutta method of order 4. Okay. And I just write the formula for RK method of order 2 also. These are two used in your papers. Yes, so what is the RK method of order 2, or it is called as Hewn method? It is basically this one. K1 is equal to fx naught y naught. K2 is equal to fx naught plus h y naught plus k1h. Then y1 is y naught plus half k1 plus half k2h. So this is the formula for another Hewn method. Okay, so you need to find k1, k2, k2 from k1, and that's all. And you can implement these formulas right in the questions. Can you?
Sir, one more thing, sir.
Yes.
They given write down the equation.
What is the equation?
X dash is equal to
Yeah.
xy
yes, it's
minus
a formula,
t.
no? Okay, sorry.
Yes, x dash is equal to
xy minus t.
x by
xy x into y.
Okay. Xy minus
T.
t. Okay.
Yes, sir. 0 less than or equal to t, less than or equal to t value 0 to 1. And x of 0 is equal to 1. One more they given y dash.
Xy minus, okay. Y dash is
two equations. Y dash is equal to x plus t.
okay.
X plus t. And same t is from 0 to 1. Y of 0 is equal to 0.
Okay. Then
From this we have to calculate y of 0.2 by Euler's method and y of 0.2 by using modified Euler's method. H they not given. H is equal to 0.2 directly.
Euler method you want to find?
Euler's and modified, sir. I have a doubt means here what they given here. X naught is equal to 1, y naught is equal to 0.
Yes.
And to determine the values we required, f of x comma y is equal to what we have to take here? The function x plus t.
Yeah.
Yes, sir.
Yes.
F of
How do you?
is x plus t, isn't it? Y
Can you repeat? I'm not able to hear you.
Here the function f of x comma y is x plus t only, no, sir?
F of x comma y, yeah, x plus t, yes. Yes.
Isn't it? That means f of x comma y is x plus t.
Yes.
Then my doubt is here x comma y is equal to x plus t. Then this is y dash actually. According to our formula, y dash is it?
Yeah.
Huh? Then y naught dash is equal to what the values we required in the modified y naught dash and y1 dash we required.
Y naught dash will be x naught plus t naught, and this x naught is already given 1 plus t naught.
That is 1 plus t naught is?
T naught is your initial value, 0.
They not given the t naught. No?
T naught is 0. This is
initial t equal to 0. Okay, x of t. Okay. Okay. T equal to 0. That is 1. Y naught dash is 1. But they given y of 0 is okay.
You understand?
Understood. Y naught dash.
And how do you find y naught, y1 dash, which is x1 plus t1?
X1
but what is x1? Yeah.
X1 dash we have to use this one.
X1, how do you find x1? You need to use first equation, right? Then you find out.
X1 is equal to, here h is 0.2, x1 is equal to 0.2.
Yeah. T1 is 0.2.
T1 is 0.2. Okay, T1 is 0.2. Then what is the x1?
X1 you find using the Euler method.
Okay.
Yes.
There we have to use, again you have to substitute that by x1 value to get y1. Okay.
Yes.
Okay. Same two questions are based on this equation only. One is Euler's method and other one is modified Euler's method.
Okay.
Okay, sir. Sir, you post this video immediately, sir.
Yeah, I just pause immediately. This is the last one.
But this is the last class, or will have any?
They have not scheduled any other class, I think so. I have not got any email regarding that.
Okay. What will be the pattern of the exam?
The exam questions will be related to what we have discussed, but they will be like they will be easy to understand, I think.
Okay, sir. Based on the assignment questions, if you prepare like that, only will get.
So there is ratio, like for assignment questions, you get like, I think 13 questions from assignment, 13 open. Okay, 25 assignment questions, 25 open, 25 like that. Recall.
Okay.
Yeah. But you will be able to do half of the paper, at least 50%. Easy.
Sir, one more, sir. Some of the questions we didn't get, we got the answers wrong, and how to know that one, how to get that one correct answers. We didn't get any key for
in assignments or
assignments, sir. 12 assignments. Some of we did the correct only, but the answer is not matching, and we don't know where we did the wrong.
Okay, so
we identify that one.
Solutions are not provided to you, or
What's that?
So solution of the assignment questions.
We didn't get the solution of the assignment. Only a fifth, then they given the solution, but others they not given any solution.
Okay, I will say them to provide.
Please provide, sir, all the 12, so that where we did the mistake, we should know that one.
Yes.
Because if it, we don't know the who are attending the classes, and we don't know any.
Yeah. But I tried to discuss here most of the questions, right?
You tried it, but when we are doing some problems, we are getting exactly.
Yeah.
And after that, it modified the answers given something. But we should know that what the mistakes we committed, we should know.
Yeah. I will ask.
If it is compared with the key only, then only we can know where we commit the mistake.
Yes.
Isn't it? Okay. Simply we are know the answer, it is correct or wrong. But if it is the wrong, where we did the mistake, we are not getting any idea about that. So that if you provide
then solutions are good.
Solutions, if it is there, then we can go through so that it will be very easy for to attend the exam.
Okay. So when is your last assignment submission date?
Wednesday, sir.
Wednesday.
Okay. Every Wednesday. This Wednesday is 17 and 28 is exam.
28 is the exam. Okay.
Okay. Before that, if you have the solutions of all the assignment.
Yeah. Maybe I just take it from them and add it to our folder. That would be good. You are able to access these tutorial files?
These tutorial files I'm accessing.
Okay.
Everyone is able to access that one, so that we should have the keys. Solution.
Yes, Mayuresh here. If possible, can you also upload the, you have discussed many questions, you know, and there were some of the questions which were not discussed. Some, yeah, so those papers also, if possible, can you upload?
Okay, I will see, like which questions you are
PDFs.
saying about?
No, I'm asking about every week there are PDFs which you are showing, no, and from there you are taking snapshots.
Okay, these assignments and okay, I just upload these questions, yeah.
Yeah, all entire questions of every week, if possible, and can you please upload?
Yeah, I will.
Yes.
These questions and that solutions of our assignment also will request.
Okay, yeah.
It will be very.
Yes, actually, yes.
I will also provide the solutions of these tutorial questions, maybe.
Okay.
Assignments, answer key for maybe the old answer key. Yes, Mayuresh?
Yes, actually, there would be a summary session, no? Like last week I had another exam. So just before that, 3-4 days before the exam, we had a summary class. Okay, if possible, you can just see.
Okay, I just asked them, maybe they haven't, I have not got an email regarding that. So is this will this be happen this time
only
also?
Next week only the one last it may have possible, sir. After that exam only. After that.
One session you want? Okay.
Yeah, that will be really nice.
Okay.
Just revise all the topics and which one we can.
Yeah, I will discuss, maybe I want to discuss exam related queries or exam related questions. That would be.
No, probably once we go through entire assignments, no, we also may have some doubts, and it will be easy to discuss over the call.
Yeah. Okay.
And one more, sir, you upload the solution set and we'll
okay, first see the solutions, yeah. Then
so that we have where we are stuck and why it is we are unable to, we didn't get the idea, so that we can discuss it.
Yes. Okay.
Because we did somewhere that we should know.
Yeah.
Okay, sir. Please upload this video as well as that.
All right.
Yes, Sharavan, here a small point from my side. Probably I don't know whether others also feeling the same way, but for the last session, maybe last 2 weeks, we are having the sessions taken by Madam, where it was going through like a series of slides where these methods are explained, like Euler method, backward Euler method, and Bashforth, like different implicit and explicit methods were discussed. But when we solve a particular problem, the mode of like how to work out is given, but it will be better that if we get some examples, clear examples to understand. Otherwise, it is like scheme, like the methodology was told, but examples were directly not addressed. Like earlier, I am just referring to the earlier classes and the last 2 classes. I don't know what about others. I am unable to quickly get the information because earlier series it was like in a continuous way it was going from one session to other session. We like I was able to follow continuously for the methods plus examples that way. So suddenly when there was a change, only like the example is not there, but overall the scheme of this one was explained.
Yes.
It's better that if we get some examples also.
Yeah, you can do assignments. That's all I can say. And yeah, if you want more sessions, okay. But you are in touch with my email, right?
Yeah. And one more thing, actually, question and assignment number. Yeah, assignment number 10. We have raised some question. Probably in that QA, there is some conversation group is there. Probably I don't know. Earlier we were getting some response, but last I think last say after April, no response has come. None of us would have got any response. That's what I believe. A lot of questions were raised in that assignment number like 10, week number 10. assignments
Week number
1 and
10,
2.
yeah. I have got an email regarding 10th assignment. I just discussed that with them.
Yeah, but no corrections happened after that, it seems.
Okay.
Yeah.
I will see. I just check and reply to the tutor to email.
Yes, just last one point, Yash. Just last one point.
Yes.
Actually, this Range Kutta methods which you have written, no? Actually, there was one additional H in that. There is a mistake, I guess.
Which one? Which?
Yeah. In the Range Kutta, no, just now you have written. If you can share it again.
Yeah.
H by 6
I
will
think.
be there. H
Oh.
by 6.
No, H is coming here. You can see.
Yeah. So there should be that. There should not be one. Yeah, just go down. RK2. There should not be one addition. Okay. Because H is not there in the K1 and K2 in RK2. That's why you have brought H here.
Yes.
Yeah, and in the, can you go little up?
Okay, I can add it here. Note.
Okay, right. Clear.
Okay.
Yeah.
All right. See you all the best for exam, and I will try to take one more session. Yeah.
Sir, upload this video, sir.
Okay, yeah, I will upload by today. Yeah.
And probably for that last session, you can cover like full tutorial, like whatever we have taken, maybe covering all these aspects.
Okay, all the tutorials, some questions from all of them. Yeah.
Yeah.
Okay.
And even if it is numbers are more than 10 also is fine.
Okay.
Yes, is it possible to discuss for another 2 minutes? Yes, I have 1 or 2 doubts.
Possible? Yes.
Can I share my screen?
Yeah, you can.
Yeah, okay. I'm sharing assignment 11.
Yes.
Assignment 11. No, there are 2 questions. Question number 8 and 9. So if you see this question number 8, let me zoom it. Yeah. For f of x cube.
This is from assignment number 8. Okay.
Assignment number, no, assignment 11.
Okay.
Assignment 11. So f of x is equal to x cube. And it is asked to find out the global error of integration between two x values by the trapezoidal rule. So first of all, there is no limits of integration were given.
Yeah, it is very
so
hard.
That was the first we could that was the first point where we stuck. And had it been given, in that case, this trapezoidal rules global error is nothing but h cube by 12, no, f double dash xi.
Yes.
So okay, if it is given, that can be directly applied, right?
Yeah.
H cube by 12 into f double dash xi, is it not?
And there is no h given also.
There is no h given also. So all those.
So this is missing information here. There is some type.
Okay, let us. Okay. And this question number 9. Question number 9. This is what is the how small must h be for the trapezoidal rule to attain an error less than 0.001 for this limit? Yeah. So this looks to be relatively simple question. I could solve it and I got some other answer. 0.09 was my answer.
Okay.
Yeah, but okay, it's somehow not matching now. It is 0.05. So here also, as it is trapezoidal rule,
the question is correct.
We could so 0.001, that's the error. That should be equal to h cube by 12 into f double dash xi, is it not? And xi to be taken for this function, we have to find out at 2.8 and at 0.2 what are the values of this function at f double dash, and the maximum value is to be taken.
Yes.
Am I correct?
Yes.
This is f of x. So this is f of x. So f dash x and f double dash x, and f double dash x to be found out at 2.8 as well as at 0.2, and the maximum value is to be taken. And that into h cube by 12, that should be equated to the error. So that is what we did, and I got 0.09 as the answer with that. But okay, so that
I will share the solution. Maybe there is some issues with that.
No, because no, I just wanted to know because because concept
so that it will be useful for us.
Concept you has done with right concept, Mayuresh.
No, but I just wanted to know because if at all there is a mistake in my concept,
Okay.
again, I may make a mistake again in the exam. Just wanted to double check.
Okay, that's why I want to share the solutions to look at your concept.
Yeah.
Maybe calculation error in the solutions also, we don't know. But just share the solutions. Yeah.
You'll be sharing it later, right?
Yeah, I will be sharing it.
Not now, right?
Bye. Not
Yeah.
now exactly, but I will be sharing.
Right.
I will have to email them for getting the solutions in.
Thank you very much.
Okay, Yash. Thank you, Yash.
Okay. All right. Just go through with the formulas mainly. I think the need is to practice more and more, and let's just apply your right concept and everything. Don't worry about the correct answers or not, but they matter. But yeah, if you're writing your concept, I think everyone is doing the same. So if there is any error also, then it doesn't reflect much in your
Problem is that in online there is a answer is like only one. So if that is not correct, then we will lose it. But for us, that values like percentage values are like slightly more for our like current coursework, whatever we are doing.
How much is that?
It is it should be minimum of 60. We should get 60. Minimum 60 and above, and whatever assignment course counts only for 25% of it.
Okay.
So even if we write the concept, because these papers are not going to
25% are assignments.
Yeah, 25% are for assignment.
And how much you scored in? Is it fine for how much?
Yes, but even if we say take 100, it will be 25 of it, right? So 25 marks. Okay. So balance should come from the
mainly exam is more important.
Yeah. So
the total it should be 50%, or in the exam also we should get that after that 50% in this assignment, including assignment total we should get 50% exam.
Yes.
To get this, including assignment.
Yeah, Madam Mayor, actually NTPL requirement is only 40. You score 40. Above 40, you will get cleared. But for our case, we need more than 60.
Okay.
To get the certificate, 40 above means this 25%, it is also included in that 40. Not only,
yes.
The external.
Yes.
Total, it will take maximum, which is the maximum 8. All the 12 they will consider.
8 of 8, best 8 of best of 8, I think, out of 12.
Best of 8.
Okay, thank you very much.
Yeah, sure. Thank you very much.
Thank you.
Bye.
Thank you.